Now the class is being recorded. So we're going to learn about how to design databases, all the best practices involved in designing databases with projects involved for you to do work on. And then we'll learn how to create our first table in SQL, right? How to put data into that and learn how to manage indexes. So chapter 6 talks about indexes. Chapter 7 talks about compression. How do you compress the data? When information becomes too big, how do I pull them to compress, to become small in the database? We're going to look at that. And we're going to talk about partition. If the table becomes too big and I want to break it down into smaller tables, how do I do that in SQL? Now we'll talk about that in chapter 8. Now, snapshot, right? Just like you take a snapshot, a picture copy. You can also do a snapshot copy of a database, right? How do I do that? What is it used for? You know, if someone breaks something in a database and you have a picture copy of it called a snapshot, you can reverse that action using a snapshot. We're going to look at that in chapter 9. And now this is the only section that we're going to look into a little bit of queries, right? Writing code, right? How do I pull data from a table? If information is already on the table, writing select statement, query, joins, inner joins, and DML operation, function, store procedures. These are the queries that we're going to run in this class, right? Very basic, just for you to understand how you can pull data from a table. Because what is the reason to save pictures on your phone and you cannot access those pictures, right? You should, when you save data on the table, you should be able to access that data when time reaches. So that chapter only takes care of that. And then views. Views just help IT teams to help other people that are not really IT savvy to be able to read data from the table, right? People that might not have necessary access to the database, we only want them to see what is in the database, their views. For example, when you go to the bank and you create a bank account, they are giving you a view, a read-only access of your bank account. You don't have the option to log onto your bank account and do some changes. I wish I had that. I mean, every single month I will go to my bank account and add a couple of zeros behind every balance that I have, right? So because you don't have that, you only have the view option, you cannot make changes to your bank account, right? So we're going to look at that. How do we make that? Make sure that users can only look at the data, at the information that is in the database without having option to change it. And then we're going to look at triggers. How do a bank actually send out an alert to you if someone tried to swipe your bank account and the bank realizes that this is a fraudulent transaction and blocks it, and you get a text message, did you authorize this transaction? Those things are called triggers, right? It triggers an alert and gets sent to the user to notice that someone is trying to use your account. If that is you, say yes. If no, say no, and then they'll block it. That falls under trigger. And then we'll start learning other technologies like replication technologies. Like, how do I move data from one location to another, right? You go to a bank branch. Bank of America has branches all over the country, right? But at the end of the day, that information does not stay at the branch. If you break into a branch and you're expecting to steal that data at the branch, you're wasting your time because the data is not there. The data is saved in a centralized location through a process of replication, copying of data across. How do I copy data, move data from one location to another? That's what we do here. And then we'll look at maintenance. How do I maintain a database? We all know of car maintenance, right? You cannot drive your car and you don't maintain it. So when you drive, you maintain. When you manage the database, you maintain the database. So all these things here talk about database maintenance, all this, database maintenance, maintenance plan. And then monitor. There is no way a DBA will not monitor the environment. You need to know what is happening in your environment. You need to tell when someone cannot log in. You need to tell when the server is full, if the drive is full, and all those kinds of things. How do we monitor? We talk about that in chapter 20. Then we have automation. How do we look at automation in SQL Server? If I want SQL Server to do things for me, because I don't want to wake up at 3 a.m. and do the activity, how do I scale that? There is a way you can do it, and then SQL Server will do it for you. Like WhatsApp. At 2 a.m., WhatsApp takes a backup of your WhatsApp messages. Do you think someone wakes up every day at 2 a.m. to do that? No, it's not. They don't do that. It is automated. This is very simple technology. You set it up. When the time reaches, a trigger gets fired, a backup is taken, and your messages are backed up. That's how we do this. And then security. We look at security, like we need to know who has access to the database, who should be able to access the database at what time. All security measures that need to be put in place, like encryption, transparent data encryption, always encrypted, data masking, how you can, most of you need to see that all the time when you are filling a form and the security, social security column, all the numbers are X out except the last 4 digits. How does that happen? That falls under data masking. You can mask the first few digits of a social security number so that the individual only sees the last 4 digits for security purposes. Also, email address, you can mask the first side of the email address and leave only the last side of it. That falls under security, data masking, and how you can encrypt the database so that if someone steals a copy of your data, the data is encrypted. You cannot restore that database unless you have the encryption key. You watch that all the time in movies. Database is encrypted. People log into a server. They hack in, they try to get the data. They cannot access it because the data is encrypted. So that's what all this falls under chapter 22. On 23, we talk about very beautiful stuff. This is a chapter that you should know it before you leave this class. High availability solution. These are things that you do in your environment to make sure that that data is always there, no matter what. Whether there is fire, there is flood, whatever disaster, the data will always be there. There is no outage allowed. Some companies will not allow you to have a session where you complain that the system is down. Some companies, when they say the system cannot go down, they have to implement things like that. For example, World Trade Center, right? When you go on trading, when there's trading, 1 second, when the system goes down, the world suffered a lot of loss. So that's a system that cannot go down, right? The New York Stock Exchange cannot go down without being programmed. You have all different types of technologies that you can put in place to make sure that that system is always up. It doesn't go down. And this falls under high availability solution. Disaster recovery. What happens when Harvey struck here in Houston 2 years ago? All those database servers that were here, did they lose the data? No, because they have something in place that is called a disaster recovery technology that has been put in place to recover the database, right? And all this falls under that. We talk about tuning databases. When most of you right now, if you try to log on to any app and it's taking more than 1 minute to log on, nobody will be happy here. You want things to be fast. Then you click, it works. You click, it works. That falls under performance tuning. How do I optimize the server to work at a very high speed? We all need things to work fast. Database administrator takes care of performance, right? So 26 talks about that. And as you can see, that ends the fundamentals of this class, right? When we end chapter 26, we're done with fundamentals. Now the last part will be project phase. This is where your capstone project comes in. We're going to help you build a lab environment, virtual machines. That's why all the virtual machines now are important. You need to have the right laptop to be able to do this. We'll build virtual machines for you. And when we're done building the virtual machine, we're going to restart all the projects again from scratch. You learn how to install SQL Server. You learn how to do patching. You learn how to do upgrade, log shipping, decommissioning, replication, all these kinds of projects. Every single project here is a corporate world project. And when you're done with this, we are going to go on interview grilling. Grill you one by one. You're going to face the committee of 5 or 6 DBAs. They ask you questions. They train you how to answer interview questions. They tell you what you're saying wrong, how you should say it during an interview. And I'm telling you guys, with this package, there is no reason why you should not have a job if you do the right thing. So you see, the program is intense, but it's not difficult. It just needs you to create time to listen, come to class, do your homework, and I promise you within the time frame that we have here, we will be able to cover this with no issue. It has been done over and over and it's proven that it works, right? So let me stop here. I see there are a couple of questions. Let me see. Question number 1, can a computer monitor works with any laptop? Well, it really depends what type of monitor is it. If the monitor is an old monitor, it might not connect. So long as that monitor can connect to the laptop, fine. Most monitors that use HDMI output can connect to most laptops, most of these new laptops. But if you have a monitor that connects with a VGA, that flat top head, you might need to get an adapter to be able to connect to your monitor. But if you have a monitor and you're having difficulties connecting, reach out to me. I will help you how to connect them. I will tell you what you need to connect to them. The next question: how do you go about the second monitor? Well, if you have a second monitor and it's connected and you don't know how to use it, I can help you set it up for you. All right. So let's stop here because sometimes I forget to record. All right. So we're going to talk about computer basics, right? Computer basic. I know that most of the things I'm going to be talking about here, most of you already know it. What is even a computer? Why do we need to understand this? Well, the thing is, not everyone is versed with this. And if you want to go into an IT field, it's good to understand everything from the basic. Get the basic understanding of what you're going into. So, and we have this certification that are available. I told you guys during the orientation class, this certification will be retired in January, but you still have the option to take it before January. And even when it retires in January, you have 2 years to take the certification to be valid before it can go ahead and dissolve it. So how can I pronounce your name? Abiodun, right?
You good, Abiodun.
Yeah. All right, Abiodun Olawud Tosin, yes. So yeah. Welcome. I know you joined later on, so you came when everyone has already introduced themselves. So all right.
Yeah, I'm with you guys.
All right. Okay. Welcome, sir.
You're welcome.
So we're going to go ahead and talk about what a computer is all about. What is really a computer? And for you to understand what a computer is all about, let's start by looking at a hardware, a difference between a hardware and a software, because this makes up part of a computer. What are really the differences, right? So even before we talk about, let's look at it. So a hardware, like we talk about a hardware, is any part of a computer that has a physical structure, right? So this could be a mouse. All of you use a mouse. That's the hardware. It could be a keyboard. That is a hardware. You have a screen. That is a hardware. You have the computer. Inside the computer, you have drives. You have RAM. All those things, the physical things that make part of a computer is hardware, right? So for some of you who did computer studies back home, you went and you did computer engineering, you talk more about hardware, how to deal with hardware. You will really not do a lot in this class with hardware because that's not what we're training you to become, but that's what a hardware is all about. But now, how does this then? So if you look inside every single computer that you open, then you have this. This is called a motherboard. I'm going to come back to it later on, right? A motherboard, which actually has all the components of the computer connected to it. That's why it's called a motherboard, a motherboard. But we're going to come back to this later on. But now, how does a hardware differentiate itself from a software? Well, all of you have been using software. There is nobody in this class that will tell me that he or she has not used software. If it's just this Zoom that you're watching me, that you were able to connect to Zoom and log into this class, that's a software. And that software connects to a hardware to be able to make the connection to whatever you're doing. Any application that you use is a software, right? So Microsoft Word, all of you have most probably used Microsoft Word. A Microsoft Word is just a software. And the software connects the connections with a hardware. All the resources that the software requires are provided by the hardware, right? So this is just a very simple example, a PowerPoint presentation I'm showing you right now. That is a software, right? Just a simple internet website. You go on a website, you're browsing pages from one page to another. Those are software. Hardware is providing those resources because every single time you open a computer, you are making the two things that are involved. The hardware and the software will be involved. The hardware is the computer itself, the memory, the RAM, the CPU, the disk, right? Those are the hardware components of the computer that makes sure that the software that sits on the computer, which is like a program like this, the Zoom, internet, whatever you open, it's that software that is using the resources provided by the hardware. So that's just a very simple example between the hardware and a software, right? Now let's go a little bit deep into what it's all about. All right. So like I said, everything you do, all the interactions, they go through that. Now let's look at this now. What are different types of the computers that you have? All of you use computers. There's nobody here that says has never used a computer, because a phone is a computer. And inside a phone, you have the hardware component of the phone, which is, it has to do with the processors that are inside the phone, the storage that is inside the phone, the memory that is in the phone, and that is a hardware component, right, of that phone. Now, that is a computer itself, because on the phone, you have applications that are running on that phone. Those software, they run on your phone. And you have all different types of computers that you will use, whether it's an iPad, it's a laptop, it's a server, it's a phone, it's a GPS, those GPS that you hang them on the phone, all those things, whether it's an ATM machine, all those are computers, right? So you have all these different types of computers that you already used to. Now let's take a different look at it, right? We all know about this. When we talk about computer, the only thing that comes to your mind is this. But there are so many different types of computer that you know. This is a desktop computer, which is what I have here in front of me. Now you have a laptop computer, and then you have a tablet computer. You have a phone computer, even the smallest calculator that you know, that you punch, that is also a computer. And you have servers. Now, as you go higher in the list, now you get to the point where we start talking about servers. Servers are computers, and you are becoming a database administrator. All your life throughout this career, you're going to be working with servers. And this is how a server looks like. I'm going to tell you that for your entire career, if you are very lucky, you might have a chance to get into a server room maybe once or twice. I have been once in the server room, right? I work every day on servers, but you hardly get a chance to get to a server room. Why? Because it is highly secure. And most of the time, even when you leave and you go to your job, you never work locally. Your server is never sitting in front of you. You are always going to do a remote connection to your server. That's why this job doesn't really care where you work from. So long as you have internet connection, you can work anywhere. The only restriction that you can have is that a company policy will not allow you to work remotely. But even when you drive to work and sit on your cubicle or your office, you are still going to work remote, because the server that you are doing your job will never be in your office. It's always going to be in a data center. And most data centers are located in the far distant locations, right? It might happen that you get your job location is also on the same data center location. But because of disaster recovery, you always have some data centers located somewhere else, right? So you are always going to work remotely. And most of us are already been working remotely. When you create an email, a Gmail, and you send emails, you log onto Gmail, where do you think you are logging onto? You are logging onto a server, a Microsoft server that sits somewhere in the cloud. Right? When we talk about the cloud, it just seems as if it's hanging in the cloud, really. But it's just that it is remote in a different location. Right? So you are always in this field, always going to work remotely. Always going to be remote. So now let's look at how the data center really looks like. I mean, for those of you who watch movies, you would have already realized that in most movies, you're used to this kind of environment, right? Where you have a room, a server room with all these server racks standing like this, and you have all these computer networks connected with one another to really get the information. But what happens here is that this is a location where the temperature is controlled through cooling, the power is controlled, and everything here is controlled, because these servers generate a lot of heat. And you can test it from your computer. Just raise the back of your computer and touch the bottom part of the computer. You feel the heat coming out of it. So just imagine that on this server room, every single one of these is a single computer that you have. It has the same capability like the computer you have in front of you. So the same amount of heat generated by your computer will definitely be generated by every single one of these servers. And if you don't control the temperature in there, they are going to blow out because of it overheat and they're going to stop functioning. So a server room looks like that, and you have a lot of racks left and right, and everything gets controlled as temperature-wise. And I'm going to show you guys a short video here that actually looks into Microsoft data centers, right? Microsoft data center. Even before we go into, let me actually get a YouTube video that takes you deep inside a Microsoft data center to really see how a data center looks like, right? Okay, so I can take a tour of a data center. Let's look at this, for example.
A data center is the brains of the internet, the engine of the internet.
Let me get the volume a little bit higher.
With a lot of power, a lot of cooling, and a lot of computers.
Row upon row upon row, all together to provide the services that make Google
Okay,
function.
so that's right.
Data center
So this is a
brain.
This is a short video just to have a look inside a Google data center, how it looks like. Because this is the beginning of your job, right? You are all this time, you're going to work with servers that are found on data center. So because you might never really have a chance to get into a data center, sometimes it's important for you to see this so you can start visualizing really what you're going into. All right, let's look at this.
Of the internet, the engine of the internet.
It is a giant building with a lot of power, a lot of cooling, and a lot of computers.
It's row upon row upon row of machines, all working together to provide the services.
So as you can see here, every single one of these here is a computer like what you have in front of you.
Operating data center.
Highly secure.
I'm Joe Cava, Vice President of Data Centers at Google. I'm responsible for managing the teams globally that design, build, and operate Google's data centers. We're also responsible for the environmental health and safety, sustainability, and carbon offsets for our data centers. This data center here in South Carolina is one node in a larger network of data centers all over the world. Of all the employees at Google, a very, very small percentage of those employees are authorized to even enter a data center campus. The men and women that run the...
Did you hear that? Of all the employees, only few of them are even authorized to get in here. Very few of them, right? So just because you work in Google, it doesn't mean that you can just get into a Google data center. Very few people are authorized to even get in here.
Keep them up 24 hours a day, 7 days a week. They are incredibly passionate about what they're doing.
In layman's terms, what do I do?
I typically refer to myself as the herder of cats.
And I'm an engineer, hardware, site operations. We keep the lights on, and we enjoy doing it.
And they work very hard. So we like to provide them a fun environment where they can also play hard as well.
We just went past the 3 million man mark for zero lost time incidents. 3 million man hours is a really long time, and with the number of people that we have on site, that is an amazing accomplishment.
I think the Google data centers really can offer a level of security that almost no other company can match. We have a information security team that is truly second to none. You have the expression, they wrote the book on that. Well, there are many of our information security team members that have written the books on best practices in information security. Protecting the security and the privacy of our users' information is our foremost design criteria. We use various layers of higher level security the closer into the center of the campus you get. So just to enter this campus, my badge had to be on a pre-authorized access list. Then to come into the building, that was another level of security. To get into the secure corridor, which leads to the data center, that's a higher level of security. And the data center and the networking rooms are the highest level of security. And the technologies we use are different. Like for instance, in our highest level areas, we even use underfloor intrusion detection via laser beams. So I'm going to demonstrate going into the secure corridor now. One, I have to be on the authorized list with my badge. And then two, I use a biometric iris scanner to verify that it truly is me. Okay, here we
Irish
are on the
scanner,
data
guys.
center
They
floor.
scan the ice.
First thing that I notice is that it's a little warm in here. It's about 80 degrees Fahrenheit. Google runs our data centers warmer than most because it helps with the efficiency. You'll notice that we have overhead power distribution. Coming from the outside yard, we bring in the high voltage power, distribute across the bus bars to all of the customized bus taps that are basically plugs where we plug in all the extension cords. All of our racks don't really look like a traditional server rack. These are custom designed and built for Google so that we can optimize the servers for hyper efficiency and high performance computing. It's true that sometimes drives fail and we have to replace them to upgrade them because maybe they're just no longer efficient to run. We have a very thorough end-to-end chain of custody process for managing those drives from the time that they're checked out to the...
And you see these drives, the way it looks like right now, if you open your computer, at the back of your computer, this is a hardware, it has the same kind of drive. It might have a little bit slower drive, like an HDD drive, but it's the same technology. So what you're already dealing with right now as a laptop is already a server at a certain level, right? So in most large data center, like Google data center like that, they have the same topology. It's just so many hundreds and hundreds of servers that are packed together in one location to be able to provide the internet services that you enjoy with Google.
Server till they're brought to an ultra secure cage where they're erased and crushed if necessary. So any drive that can't be verified as 100% clean, we crush it first, and then we take it to an industrial wood chipper where it's shredded into these little pieces like this. In the time that I've been at Google for almost 6.5 years now, we have changed our cooling technologies at least 5 times. Most data centers have air conditioning units along the perimeter walls that force cold air under the floor that then raises up in front of the servers and cools the servers. In our solution, we take the server racks and we butt it right up against our air conditioning unit. We just use cool water flowing through those copper coils that you see there. So the hot air from the servers is contained in that hot aisle. It raises up, passes across those coils where the heat from the air transfers to the water in those coils, and then that warm water is then brought outside the data center to our cooling plant, where it is cooled down through our cooling towers and returned back to the data center, and that process just repeats over and over again. To me, the thing that amazes me about Google and the data centers is the pace of innovation and always challenging the way we're doing things. So when people say that innovation in a certain area is done, that we've kind of reached the pinnacle of what can be achieved, I just laugh.
All right. So, Alice, this might be your only tour you will ever have into a data center, maybe for your entire career. Right? Very honest, you have people that have been working with DBA for years. They've never been inside a data center. Right? And you might never ever get in there. So I got a couple of questions here. What is the role of the server? Right? What's the role of the server? I mean, first of all, what is a server? A server, this is, when we talk about a server, there is really no different from what you have in front of you as a computer. A server is just like a computer that provides computing services, the computing resources, like computational time, the memory, the RAM, the disks. It's just like a computer on its own, right? That you can run some computational work at a higher speed than the regular computer in front of you. It's built up the same, but it has just a higher capacity than a simple laptop that you have in front of you, right? So, and it's used just for this kind of activities that we're talking about. And how many computers can connect to a server? Well, it really depends on how you want to make the connection to a server. When we talk about a computer connecting to server, if you want to do what is called a remote desktop connection, if you want to remotely connect to a server, you can only have 2 remote desktop connections. And I'm going to show you guys a typical example. I hope my servers are up here. I have a lab environment here. Let me see if it's still up. I can show you the real inside of what a server looks like. Yes. So I have, this is what at the end of the day, end of this class, I expect you to be able to build environments like that. I do have one single computer in front of me, that I've virtualized it and I've built these different servers. So every single one that you see here is a server on its own, running independently from one another. This is called virtualization. You take one computer and you make hundreds of computers from it. Right? So right now, because I have virtualized this, I can literally connect to this. This is why I right click here and I can say connect. Because it's running, it gives me this remote desktop connection. So I'm remotely connecting now to a different server. Other than is completely different from the computer that I have here. I can restart this one, I can shut it down, and so on. So it gives me an option to connect. So I can literally just connect to this one. So connect cluster admin, and I can do a connection. This is something that you're going to learn it later on in this program. So you can see I am signing in now onto a server, remote server. So when you do this to sign into a server, we call it a remote desktop connection. And you can only have 2 connections at once. So I hope that answers that question. You can only have 2 remote desktop connections to a server. But now, if you have an application, like a database running inside this server, and users have to connect to it, it really depends on the specifications of that server, how big the server is, and how much it can carry. But if you need to remotely connect to it like I've done right now, so you can see, I can literally get out, I'm out of the server. Now I can click here and get back inside the server, right? It's different from the one I have here. If I want to restart, I can literally right click here and restart this server. Let's say restart. With that, you see, it's restarting, but my computer is still running, right? Because this is different from the computer that I have. It's just called a virtual machine because it remotely connects to it and it connects. So I can get out, you see, it's shutting down here. No, it's shut down already. It was Houston. No, it's shutting down, right? So another one is here. I can do the same thing and connect, you know. So these are servers, and that's what we try to help you build when you leave this class. So you have this like this. It looks just the same like what you have at work. If I get a project at work, I can come in here, open it, test it, make sure I validate it before I implement it at work. Very, very important. Okay? All right. Now let's move on. So now we are going to look inside a computer, right? We're going to, and when I talk about inside a computer, visualize a server as if it's a computer. I mean, a server is a computer. It's just a bigger computer. So now, what is it made of? I talked about a motherboard, right? This is the motherboard of every single computer. You have the motherboard. And this motherboard is the main circuit board of every single computer. Right? It's a thin plat that holds a CPU. I'm going to talk about the CPU later on. It holds the memory, connectors, and all the connections to the hard drive, optical drives, and all the video or audio connections to the computer. Like, so for example, the USB. When you get a USB stick and you stick it into your computer, you are sticking it directly into the motherboard. The motherboard holds everything together inside the computer. And now let's look at some of the components. For example, I spoke about a processor. If you look at it here on this motherboard, if you ever open your computer, the inside of your computer, this is exactly what you're going to see. Now you can see this white port here. This is the processor. I'm going to tell you what a processor is used for. Now look at these ones here. This white stuff here. Oh no, this one's here. This is where you have your memory. And like I told you guys in this class, the required memory for this class is 16 gigabytes. But if you have the option to upgrade, let's say you buy a computer that has just 8 gigabytes and you want to move it up to 16, you have the option to open the back of your laptop and switch one of these memory cards and improve your laptop to 16 gigs. And then I do this all the time. It's very simple. You just need to open it, plug it, put it back in, and then you close it, and that's it. Right? So that's, and all that connection is made directly on the motherboard. The motherboard holds that. Now let's look at one thing here, which is the CPU. Right? The CPU. What is a CPU? Right. Now I get a question here. Optical drives. So you have different types of drive. You have the standard the solid state drive, the hard disk drive, and so on. So it really just helps you on the connection, the speed of which this different drives just helps you the speed to speed up your computer. For example, a solid state drive, when you go to buy a computer, you see that the solid state drive computer are more expensive than the HDD drive. And the essence behind this class is today is that if I give you $1,000 to go to Best Buy and buy a laptop, now I want you to go to Best Buy and be able to tell me why I'm choosing this laptop. Because when you go there, you see those numbers. How many of you really know what those numbers stand for, right? And you see two laptops looking just the same. HP, standing there. Another one is $1,000, and another one is $360. And you begin to ask yourself, why? Why is there such a big difference? Now, this class will help you now to understand why some computers are more expensive than the other ones, right? So a processor, which we call a CPU, Central Processing Unit, right? It's located on the motherboard. And when you open it, this is how it looks like. When you open it, you see these things like that. So it's the brain behind every computer. The processor is the brain behind every computer, right? It carries out all the jobs, all the commands, all the keyboards as you type in the keyboard, all that is transformed by the processor. It's just like your brain. When you sit here and information is flowing around, you are able to process that information, right? If you call my name, I process that this is my name. You call another person and you gather information. That is processed by your brain, the processor. And this processor is the speed at which information is processed by the processor determine the price of the laptop, right? The higher the processor, the processing speed, the more expensive the laptop is, and then the faster that laptop is. For example, now, processors are measured by the unit, megahertz, right? A megahertz simply just tells you that computer can process millions of instructions per second, right? Just think about it. In 1 second, the computer can process millions of instructions, right? But even though a computer is processing millions of instructions, it's still not as fast as a human brain because this was developed by a human brain. So you can now begin to imagine how fast and how powerful a human brain is because these things are designed by a human brain. So you can also have the measurement given in gigahertz. A gigahertz simply just tells you that computer is capable of processing 1 billion of instructions per second, right? Right? Billions of instructions per second. So now, when you come in here now and you begin to see how a hardware and the software plays with the operating system, with all this, you can begin to see that here. Okay, this is a hardware. A processor is a hardware, right? A processor is a hardware. And now I am displaying this PowerPoint slide to you through a Google, as a software. This PowerPoint slide is a software. But when I click the mouse, when I move my mouse is moving. How does the computer realize that my mouse has to move when I just do this? Because my mouse is a hardware. It's supposed to, the processor, which is a hardware, sees this information and sees your movement of your mouse, process that, and sees that when you move your mouse or when you click here, you are telling your computer to move the software to the next page, right? So this works hand in hand. And so the faster the computer is able to gather this information and process it, the faster the system is, right? There are some systems, have you ever worked with a computer, when you click next, it takes time, it's turning and it's turning and it's turning, and you're wondering what is going on? That's just a system to tell you that the hardware components that is part of that system is slow. And if at the end of this, we are going to look into see how you can look at the properties of your computer and be able to, why is someone telling me to share my screen? You don't see my screen? Well, let me stop sharing here, but I'm gonna share again. You guys should be able to see my screen.
I can't see your screen.
You guys cannot see my screen? Or he's the only one that cannot see my
I'm
screen?
seeing it now. See, it's okay.
See your
All
screen.
right, that might something have to do with your internet connection, okay? Because I've been
Okay.
sharing the same thing.
I'm seeing it now anyway.
Okay, thanks. So now, so we're looking at this, right? A processor, and we are now seeing that, okay, so right now when you go to buy your laptop and you see two laptops having this, looking the same, having the same capacity, and you see one that costs $500 and another one costs $1,000, maybe go and look at the speed of the processor. Look at the speed of the processor, because then there might be a difference in that. That's the reason why the other one is more expensive, right? So processors will normally, we call them the core. So you have a computer that has one core, two cores, three cores, four cores, five cores, and so on, right? The higher the number of cores, the more the expensive laptop is. And now let me now explain to you how you can really relate this. When you have a computer that say, when you go to Best Buy and you see a dual core, quad core just simply means that that computer has two processors. Now, what happens now here is now, look at it in this way. If a human being could do only one thing at the same time, like for example, you as a human being will have only one core, because I cannot be physically present here and teaching you guys and then sleeping at the same time. I can only do one thing at the same time, right? So which means that I don't have the option to do multiple things at the same time, like physically as a human being, not like, you know, human beings can multitask, but as a human being, physically, like sleeping, shopping, and at the same time. But if I was able to replicate myself into multiple cores, right, I have the option to run parallel transactions at the same time. I could put myself here teaching, have one of myself sleeping, another one is cooking, and one is downstairs chilling and relaxing, right? That's how a computer, when you go to buy a computer and you start seeing those number of cores going higher, that just tells you how many parallel processes that computer can process at the same time, right? So you need to look at it in that direction, you know? So that's how a processor helps the computer. It processes those information per second, right? Okay, now the next thing we want to look at is the RAM, random access memory, right? We said in this class, you should not go below 16 gigabyte of RAM, random access memory, right? So whenever your computer performs calculation, right? When you're doing calculation, it stores that data temporarily in the RAM until it is needed, right? When you turn off your computer, that information that was temporarily stored gets deleted. And that's why when you switch off your computer, it doesn't just go off at once. It takes time and it's turned because this computer is trying to clean everything that was temporarily stored in the RAM back to the disks, right? It's cleaning up everything. So for example, now when you open a Word document, for example, if I open a Word document like this, let's say just open a Word document. Now, once this Word document is open, and I begin to type information into the Word document, where do you think this information is safe? I mean, it's not yet safe, but you have it there. The moment you start typing this information, it is temporarily stored on your RAM. The RAM stores that information. Then until you click here, save. When you save, that information leaves from the RAM and saves it on your disk. At that moment, it is permanently saved. But the moment it's here, if I just shut down the computer without saving this document, I lose it. Why? Because it was temporarily saved on your RAM. Now with all these new Microsoft licenses coming up with Windows 365, you have the option to do a restore. That if I abruptly shut down the computer, I have the option to restore it. And it will give you the option to be able to restore. But if I just close this, that's why when I click close, it asks me save changes. Do you really want to save changes or not? Because those changes were not saved, but they were temporary saved on your RAM. So everything that you are doing is saved temporarily on your RAM. And you can look at the RAM, for example, like this. Like the human brain. You can look at the human brain like a RAM, right? As I'm talking to you right now, you're listening to me. Okay, you're listening to me and you're understanding what I'm saying. But until you take a pen and write down that information, if I close this class and I come back next week and I ask you guys, what is a RAM? If you have forgotten it, it means your memory was wiped out, right? It was wiped out because it was only saved temporary in your own RAM. That information was not stored permanently. And if you did not write it down, you don't have an option to get that information until I repeat it again to you. So as an individual, you need to know the capacity of your own RAM individual. Some students don't need to write because they have a big memory. They can sit, listen, and store the information in their memory. Even after years, they can still retain that. The human brain functions differently. Now, if some people need to write it down, which means that they are not only saving the information in the RAM, they are also saving it on disks. Because if they forget it tomorrow, they can flip through the pages and see what was said, and they're able to remember it. That is the difference. Now, let's look at it in terms of the RAM and the disks. The disk is where information is saved permanently. Even if you shut down your computer, the disk still keeps that information, right? So now the RAM measures, it's measured in gigabyte, right? Back in those days when computers were very small, we had RAMs with megabyte. But nowadays, really, there's no computer that has less than 1 gigabyte of RAM, right? So the larger the RAM, the more information the computer can save, and the faster that information. So because the computer, the processors process the information, so it will not always go back to the disk to process information. What will happen is that that information will be stored temporarily in the RAM. Whenever computer needs to do calculations, it goes to the RAM, picks up, does the calculations, and provide you the result. And it's faster. Works the same like the human brain. Now, if I ask you 1 plus 1, all of you, most of the time your answer will be 2 because you know it. Why? Because it's stored in your mind. You know it already. Now, how fast will that be if I ask you 1 plus 1 and then you have to go to books and start flipping through pages to find out where did we do this calculation 1 plus 1? It takes a longer time to provide that information. But if you store it in your brain, 1 plus 1 is 2. It's faster, right? So the bigger your brain or the bigger your RAM, the faster you can process information. Same thing with computer. The bigger the RAM, the faster the information, the processors grab that information and process it and provide you with the answers. Right? So that's the reason why you need this. So when next time you go to buy a computer, look at the processor, look at the RAM, right? And look at the disk, which I'm about to talk to you right now. Now, the last thing that you want to really know under this is hard drive, a hard drive. And what is a hard drive, right? What is it all about? No, the hard drive is actually the location where information is stored permanently, right? It stores your information permanently. Let me get this one. I don't know what's going on here. Come on, guys. Why this caused that? It's got disturbed somewhere. Okay, so I'll move this one here. All right. All right. So the hard drive is where your software documents are stored permanently. So whenever you click save, for example, if I click save here, this information now is now moved from the RAM and saved permanently on my hard drive. At that moment, even if I shut down my computer, that information is saved. It's saved permanently, right? So that's for long-term storage, right? So when you open a file, right? Whenever you when you start your computer, for example, your computer doesn't just start immediately, right? It takes time to boot. What is happening is that this computer or the server is pulling all the information that are necessary for the computer to run effectively from the drive and saving it temporarily on your RAM. That's what happens. And that's why a computer needs some time to boot, and it also needs some time to shut down. Now, when you shut it down, it takes some time now to move everything that was temporarily stored on your RAM back to the drive. That's how this thing works, right? So you do this, and the speed in which this information is saved, read, write, is what is called in the IT world I/O, input and output operation, right? Input and output. So now when you go to buy a computer and you see this HDD and SDD drive, you begin to ask yourself, what is the difference between this type of drive? This is called a hard disk drive. It has a magnetic spinning drive, right? Most old computers, you have this magnetic spinning drive, which is slower than newer drives that are coming up right now called solid state drive. So the solid state drive processes information faster than an HDD drive. So when you buy a computer and you see one that has an SDD and another one that has an HDD and an SDD, you will see the difference immediately. A SDD drive, if you want to look for drive, if you go online and you're looking for drive, this is always a factor at least twice more expensive than an HDD. SDD drives are the newest types of drives that are coming out right now. Solid state drive. There are no moving parts. And that's how it looks like. A solid state drive looks like this. And they're much more expensive than an HDD drive. So a computer that has solid state drive is faster than one that has just HDD drive. Because what do I mean by faster? When you write the information to the drive, it takes time to write it down. And when you want to read, it also takes time to process that read operation. So, and we call that input and output operation. So, and that is where you actually have the differences. All right. So at this moment here, let me answer the couple of questions, and we're going to take a couple of minutes for some exercise. There was a question here. Let me see. Question. Oh, Stephanie, Stephanie, is it Stephanie or Stefan?
Sorry, this is Valentine. I logged out of my daughter's computer, so I'm sorry.
All right, okay, go ahead. What's your question? I saw your hand. You raised your hand.
Okay. I noticed my computer, the computer I want to use for the project, has a 256 SSD and 1 terabyte HDD.
Yes.
Does it make it very efficient?
So that's and exactly that's how most computers right now are coming up, right? Because the SSD is too expensive. They're going to give you two types of drive. They're going to give you an HDD drive, which is slightly slower, and an SSD, which is faster. So when you have it like that, it's still good because you still have both, right? But if you turn that 1 terabyte HDD to a 1 terabyte SSD, that price of that computer will double. But then the computer will be very fast. I'm not saying that it's bad. No, it is good. But that just tells you that if you look at that same computer that does not even have an SSD drive, you see that it will really be maybe $100 cheaper than what you have right now.
Okay.
All right.
Okay.
Someone asked, what is an HDD? The HDD just stands for hard disk drive. It's a magnetic spinning drive. This is a different. Now, if you have an HDD drive, this is how it looks like. If you ever open your computer and look at it, it looks like that, right? And an SSD drive is just a solid state drive and looks like that. And they're much more faster than this one. All right. So now let's take a couple of minutes. And this short exercise here is just to figure out what is the system information that you have on your own computer. So right now, let's look at a computer. Now that you know it, when you next time you go to Best Buy to buy a computer, you should not just buy a computer because that Best Buy guy is sweet talking to you and you feel like that's the best computer. You should be able to tell them, no, I don't want this one because of this and that. So this class doesn't only teach you DBA. We want to make sure that you're computer literate. All right, so let's do this. On your computer, if you go down here, now we are going to learn a couple of things here because this is a beginner's class. Now we're going to get yourself familiar with this. Hold on here. I think I have a question. So, okay. All right. Thank you so much, Milton. All right. So when you're asking your questions, guys, also be looking at the platform. If there's anyone in class that has an answer, because sometimes I might not be able to quickly look at that, that answer can also be provided. And if I see the answer is right, it's right. So that answer is correct. So thank you. All right. Now just look at this together, for example. Now when you log onto your computer like this, for example, you have this bar down here. We call this bar a task bar. So whenever you are sharing your screen and I tell you, go to the task bar, right? You guys are going to see it a lot in this class. We're going to dance a lot before everybody really gets settled, which is fine. Beginning is always like that. People don't get used to this thing, but eventually they get used to it. But now begin to memorize the terminologies because you should speak with the right terminology. This down here is called a task bar. If I right click, this is what it's called. This is called task bar. T-A-S-K, task bar, right? This is the task bar. So when I say go to the task bar, I mean go down here, look down here, right? And left and right is something that you guys are going to notice in this class. A lot of people don't know the left and right. Fine, we're going to get used to that. Say go left, then they go right. Say go right, they go left. Fine, we're going to get used to that. But now here, you see this round thing here? If you have an older computer, you might not have this round thing. This is the search menu. Whenever you click here, yeah, this, how do they call this? Octana? Is it Octana? These new computers that they have this, that have this voice recording. I've forgotten the name of it. It's Octana or something like that. But this one here, whenever you click here, Cortana. Cortana, exactly, right? So computers nowadays receive voice input through Cortana. You can just say it and it gets the voice input and you can search for something. But anyway, if you don't want to use that option, when you click on this, it expects you to type in something, right? So when you are searching for information, you use this tab. So if I go here, it says type here to search. So if I just type here system, and pay attention in this class, whenever you are typing something in the computer, don't expect to type it all the way to the end. When you start typing it, it will be providing suggestions for you up here. So the moment I start typing system, right? So I'll do it one more time. Now I go to the taskbar and I click, and then I start typing system. The moment I type S, right? S, it already tells me everything that you can find in your computer start with an S. Already I see here system information. That's what I'm looking for. So I don't really need to type it all the way to the end. So I will select system information. This is where we are. I want all of you to do this. This is lab time, guy. Lab time in this class really means lab time, right? You should not watch lab time. You should really do it. So system information, this page will open. So I want all of you to do this. Now let's look at what I've just explained to you right now in terms of all the things that you have on your computer. Now here you have OS. So now before I do this, you can see here, whenever you want to expand or increase, right? Some of the things I'm telling you here might sound very trivial to some people, but some people here really don't know it, right? So just watch and do it along. Now, if you want to improve, you can, if you put your mouse like this in between, you see that a two-sided arrow pops out, right? The moment you put your mouse like that, a two-sided arrow pops out. If it pops out and you press and hold, you can move left or move right, right? You can move left and reduce it. You can move right and increase it, right? You will do this a lot in this class, increasing and decreasing column, right? So here you have also the item column and the value column. So if you need to increase the item column, you see this boundary line, wherever you see this, if you bring your mouse here, not only do you have two-sided arrows, you have a cross with two-sided arrows. Are we doing it to get used to that? So if you put your mouse here, you have this two-sided arrow. If you press the first mouse and you hold down, you can drag to the right, right? As well as you can press it and drag it back to the left, right? So when I say expand the item column, I'm expecting you to bring your mouse here, press it, hold it down, drag it left or drag it right, right? Okay, so we can do it like that, drag it. Let's put it here so we can really see everything. Okay. So, okay. So here now, we're going to look at everything that I have just told you guys right now. Now, when you go to buy a computer, first thing, type system information, go in there and look at the properties. Now, the first thing that you see here is called OS name. OS stands for operating system name. The operating system name, and you can see here, I do have a Microsoft Windows 10 Pro. This is what I eventually expect everybody in this class to have it. Microsoft Windows 10 Pro. Okay, now, next thing is version. Everything you have in IT has a version. Applications do have version. Version just tells you when was it released and exactly. So you can differentiate between different releases, right? So this version here is version 10.0.17763. Build number is 17763. Right? So when you want to look for something, if I ask you, if you just go online and look for version and you type this information, immediately this thing will pop up because only one version, this is like a fingerprint. No two applications can have the same version and build number. Right? So this is it here. Now, manufacturer is telling you who manufactured this application. It's Microsoft Corporation. And then system name, if I ask you what is your system name, most of you might not know. This is what your system name. That's your computer name. And the exercise we're going to do before we leave this class is to change your computer name. I want everybody in this class to change your computer name and use a user-friendly computer name. I don't want that name that starts with www or ls laptop. If you have a name that came when you bought the laptop, I want us to change it. So pay attention how to change your computer name, because you need to have a computer name that reflects who you are, you know. So this one tells you your computer name. And if you go down here, processor, we just spoke about processor right now. And see here, it's cut off. So if I want to expand this value column, I just need to bring my mouse here on this boundary line. If I put my mouse on the boundary line, press the first click a keyboard and I hold and drag, I will expand and I'm able to see this. So you can see that my computer has 4 cores, right? 4 cores, and F is an i7 computer, a CPU, and the speed is 1.80 gigahertz, right? It therefore tells me that this computer, every processor can process 1.8 million instructions every second, right? Now, Solange, can you tell me what is the processor speed of your current computer?
It's a desktop. It's a 2.16
okay, gigahertz. So yours is faster. Yours is faster. Now I'm going to tell you where my computer, even though you have 2.6, my computer will be faster, might be faster than yours, right? Okay. Now in terms of cores, how many cores do you have?
4.
I have one 5.7.
All right. So like 4. Okay. So another person have 1.7. Okay. So you are having 4 also. So your computer is faster than mine, because I was hoping I'm going to beat you at the number of cores. But the fact that you also have 4 and your processor speed is 2, it means you have a faster computer than mine. But it's a desktop, it's not a laptop. Probably, most desktops are always having higher capacity than laptops, right? So if you see a laptop that has the same capacity, it's going to be much more expensive than the desktop. So you can see here. So now it tells me that I have 4 cores, which therefore just tells me here right now that I can run 4 parallel transactions at the same time, and each transaction runs at that speed, 1.8 gigahertz per second. So which means that if I really want to know the total, I need to multiply this by 4. So this is a computer. This computer is called a quad-core computer because it has 4 cores, processors. All right? Who has 2 here or 1? Jennifer has 2. What about you, Hilda? What's the number of cores you have? 2? Okay. All right. So you can see, is there anyone that here that has more than 4?
Now, why is it that I can't get to my start button? My start column.
You don't need to click on your start. You need to go.
Yeah, but I don't know where the Zoom would I call it the task manager is covering?
Do you have one screen?
No, I have two. I have the laptop and I have the monitor.
Okay, move that zoom to the other side. Just, you see, press it, hold it, and then you can drag it to the other side so it doesn't cover you.
What do you mean by that?
The zoom that is covering it, right? Put your mouse on top of it and move it on the other side.
The whole thing is covering the whole screen. I can't. Oh.
Yeah, me too. I'm having a similar problem. So because I'm using the other one, I cannot get access to this and know what I have in.
Yeah.
I think you guys can minimize the page.
The
Zoom page.
Can I say something, Doc?
Yes, go ahead.
Okay, so they have dual monitors. So there are two steps that they have to do to be able to take care of that. First, they need to right click on the desktop, go to change, let me see that
Desktop settings, yeah.
And then when you right click on the desktop, take display settings.
Yes.
And then when you see two monitors, 1 and 2,
yes.
Just scroll down. There's a place there that says multiple displays. Then there's a little drop down there where you click on the drop down, extend this desktop.
Yes.
The point is that I can't even access what you're talking about now.
Just minimize. Just minimize.
Let me show you what you need to do. When you
it's all closed.
No, when you
it's all closed. It's all closed.
I understand that.
Minimizing is not going through.
Maybe you can share the screen to let them know.
Hold on, let me tell you what you need to do. Your Zoom is on full screen, right?
Yeah.
Yes, you have to get out of full screen.
And how do I do that?
If you see on your Zoom, when you have full screen, you have, if you just take your mouse to the right side of that, it says exit full screen. To the right hand corner, top of the screen, just take your mouse there. It says exit full screen. You see that?
Yeah.
Okay. Yeah.
Click on that.
Mine was hidden.
That's right.
It minimized, and now you can get it away.
That's right. That's right.
All right. Now the next thing that Milton just told you, let me show you what you need to do to get it. For those
I double clicked to get it right at the top. I double clicked.
Yeah. For those of you who already have two monitors, the way you work with it is this. And I'm going to show it again next class because we don't have time again today. You have to right click on it. Just go to your desktop. Don't do it when anything is open. Make sure you get to your desktop. Right click. Go down here where you have display settings. Click on it. This is very important because I expect everybody in this class to have two monitors. So when you buy your own, this is what you need to do. Go on display settings. When you go on display setting, it's going to tell you how many monitors you have. Right now, you see I have 3 monitors, right? But you have 2, 1 and 2. So
where do you say I should do that?
All right, you need to, let me do it one more time. On your desktop, you have to right click, right? Inside your desktop, don't right click on a page open. On your desktop, minimize everything, get to your desktop. Right click.
Okay.
And go down to display settings.
Wow.
Okay, when you open display settings, you should see the number of, if those 2 monitors are connected, you see 1 and 2. I have 3 because I have 3 monitors. So 1 and 2. So you're going to scroll all the way down, keep going down to where you have.
If I right click, it's not giving me anything.
Okay, hold on. I'll do it and then you share your screen later on.
Okay.
Okay, so down here where you have multiple display, you have the option to say, if you duplicate, it means that whatever you're seeing on monitor 1, you are seeing the same thing on monitor 2. That's not what you want. Okay. If you say duplicate 1 and 3, okay, it's the same thing. But you need to select extend desktop to this display. Extend. And then it will extend, it will ask whether you want to keep the changes. Yes, keep the changes. I'm not going to go into that right now. We'll do it next week if you have the option, or I'll help you on, not next week, on Friday, on Thursday to do that. But what I want you to do right now is here. We are here on these computer settings. This is
Dr. Dennis, this is Abdul. Can I come in quick, please? I'm using my Mac here. Like I told you, I still expecting my my Microsoft computer to come in the course of 5 days.
Yes.
I think the process here is kind of a little different with the MacBook, right?
Yeah, it definitely will be different with MacBook. Yeah, it will be a little bit different. But
Okay.
the unit might rightly be the same, but it might be a little bit different. But this is what I want you guys to do when you open it. But now, the most important thing here after this is that you need to go down here. Install physical memory. You see that I have 24, right? Okay, let me just do a random search here. Henry, what do you have in terms of random memory? What number do you have in here? Henry, what's the value you have?
I don't think ever have reached that point yet, though. You find it difficult to reach this stage.
Okay, so let me ask Claudia, what do you have here in terms of access memory?
Please come again. At access memory,
Yeah, what value do you have here?
I have 8.G.
All right, you definitely have to increase that to 16. I want every single one of you in this class, it should show 16 here. You need to have 16. Right?
I have 8.
All right, so if you bought a laptop, if that laptop is new, you might, just like I told you guys, you can open the back of your laptop, buy a RAM and improve, upgrade it to 16. You need to have it because once we start the virtualization, if you don't have 16 gigabyte here, your laptop will be extremely slow. Just look at it here. I have 24, but what is really available for me right now is only 13. Where is the rest going to? The computer is using it, right? So you cannot give to a machine what you don't have. So that's why you need to have a higher memory to do virtualization. Okay, but bear in mind that your laptop for this class should show 16 gig here. The higher, the better, but at least it should be 16. But now look at it here, down here. This is what I want you guys to. Username. It tells me here, KTech, which is my own computer name, /Dennis. So my computer name is KTech. From up here, you could see the system name was KTech. But when you go down here where you have username, it says KTech /Dennis, right? It means that the username is Dennis, the computer name is KTech. Whenever you see something in IT, a name, / another name, that thing before the / is always going to be the computer name. And this / is actually called whack, right? Whenever you hear someone say whack, it means you take a /, right? So whack, so do a /. You hear it a lot. So I just say do whack. I mean do /, right? That's the way you should get used to the terminology. A whack is a /. So now this is what it is. So now that we know all this, I want every single one of you in this class to change your computer name. And the name should be a very simple name. Because there are so many exercises in this class that will need to have you use your computer name. So if you have a very long computer name, it's going to be troublesome, right? So let's go ahead and change our computer name before we close the class. I know it's already time, but let me just do this before we leave today. Change your computer name. This is lab time, guys. Lab time means get your hands dirty. Now, you have to go to this is the start menu. Whenever I say start menu, I might either call it a start menu or the Windows menu, right? So on this menu here, we are going to right click. We right click and we select settings. No, not setting. Let's go to system. We do it again. On this tab, you right click and you go to system. Just forgive me, I just want to, when you click, the first thing that pops up says, rename this PC. Click on it, and then a window like this will pop up. Please put a user-friendly name, right? Don't put a complicated name. Put a user-friendly name. You can use Dennis, your last name, or any simple name. When you do that and click next, it will shut down your computer. So don't click next so that I can close the class before you do it, right? So you're going to put a name here, click next, and it will shut down the computer. And then I will meet you again on Thursday. All right?
Okay. Is it that I should, like I had already this cloud jet talk, I had my user's name already.
Okay. If it's already said Claudia, then you don't need to
No,
rename
it was Nanjo, my last name.
What I have here is telling me your PC is being monitored and protected, and it's not showing me that. And where it said device name,
yes,
I can't get it to change it.
Okay, but let me officially close the class, and I will help you look at that so that those who want to leave can leave. Okay. So now let's stop the video here.
Doc, you said the start button and